Hey everybody, this is Mike Brennan from the National Hurricane Center. We're out here on day 3 of the 2024 Hurricane Awareness Tour. We're at the Norfolk, Virginia airport, and we're actually on board one of NOAA's Hurricane Hunter aircraft, one of the P-3 aircraft, and I'm here with Nikki Hathaway, who's a flight director and meteorologist at NOAA's Aircraft Operations Center. She's going to tell us a little bit about what the plane does, show us around a little bit, talk to some of the folks on board. So Nikki, could you just please start off with, what kind of missions does this aircraft fly? What kind of data does it collect in hurricanes?
Sure. So we're sitting on one of our 2 WP-3Ds. This is Kermit. Miss Biggie's back home doing some gravity measurements, finishing up that mission. So we're on board Kermit today. What Kermit really does is it's out there flying between 8,000 to 12,000 feet directly through the eye of a hurricane, essentially doing reconnaissance and research. So we go out, we fly, we mark this under the storm. We also do some additional experiments with our scientists on board of the aircraft, and really just capturing all the data that then we provide to the forecasters to be able to make a forecast to ultimately protect life and property.
Yeah, and the data that these aircraft collect are really some of the most important direct measurements we can get at the National Hurricane Center and really serve as the foundation of our forecast. We get the data almost instantaneously as they measure it on the plane, and as we walk around, you sort of see that the aircraft has all these workstations, that all this workspace. It's kind of like a flying laboratory.
Flying science lab.
Flying science lab in many ways, and collects so much important data. So, but I know we've got one of the things we want to show people is one of the instruments this aircraft deploys is called a drop sonde. So it measures wind speed and direction, temperature, pressure, moisture from the aircraft down to the ocean surface. And so Carrie's going to tell us a little bit about that.
Yeah, so I'm Carrie, I'm one of the flight directors as well on board, but today I have for you one of our drop sondes, just as Mike recently mentioned, and what this instrument essentially does is it's going to get launched out of this tube here while we're in the storm, and as it drops, it's going to deploy a parachute, and it essentially drops all the way down to the ocean surface, on the way measuring pressure, temperature, humidity, and wind speed until it hits the ocean surface. As mentioned, it does transmit that data in real time back to our aircraft, where we do a quick quality control check, and then we make sure that it was functioning properly before sending that information off for that model industry.
Yeah, those data are really important to help us determine what the central pressure of a hurricane is. We drop a drop zone right in the middle of the eye, and it can also give us an idea of what the wind speeds are looking like at the ocean surface, which is really important because that's where people live. So Nikki, how many people are typically on the flight during a mission?
Sure, I would say on average probably around 15. We can go up to about 20 if we had a full crew complement.
Okay.
And that's composed of engineers, our maintainers, our technicians, our meteorologists, navigators, pilots, flight engineers. That's the entire team. So a lot of different types of responsibilities and roles on board the aircraft. Every single one of those people make the mission possible, right? Everyone does their one job to the best of their ability. When we all do it together, we got the objectives done.
Yeah, so it's really a big team effort. So I guess we're going to walk through a little bit of the rest of the plane here, all the way up to the front, and Nikki can sort of point out some things as we move along, but there's different workstations, different research scientists, operational folks here on the plane that are collecting, processing, quality controlling all the data so that we make sure that the data that comes to us at the Hurricane Center and that goes into the forecast models is the best it can be.
Absolutely. I mean, so here in the main part of the cabin where Mike is standing actually is where one of our most important roles, I would say, is this is the individual who's actually making sure that all the data that is leaving the aircraft is in fact leaving the aircraft, right? Real-time data is going to be of most value to the forecasters and to the researchers too out there. So we want to make sure that whatever we're collecting is actually being disseminated properly in an efficient time. And so this role is specifically doing just that. The data that's being collected, is it getting off the aircraft? Is it going to where it needs to go so that the forecasters can use it appropriately?
Yeah, and again, that's such an important piece of this, is getting the data in real time as quickly as possible. Sometimes that data matters in a matter of mere minutes or seconds in the forecast process. Can you talk a little bit about the different kinds of radars that are on board the aircraft?
Sure, yeah. So we have 3 on board our WP-3Ds. We have the tail Doppler radar. That's what makes the P-3s rather unique in terms of reconnaissance. So what the tail Doppler radar is able to do is it's scanning vertically. So we're getting a lot of structure out of that type of data. And that's really critical to not only the researchers, but the forecasters. When you think of Genesis, tropical cyclones really spinning up, we want to know, what does the structure look like? How is it oriented? Is it tilted? Is it vertically stacked, right? These are some of the things that the meteorologists are interrogating, and that tail Doppler radar data is vital to that. So that's one type. We also have our MMR, our multi-mode radar. It's the big black M&M underneath our aircraft in the belly. It's scanning 360. We're using that both tactfully and also for some research too. We're able to send some live screenshots of what the eye might look like to NHC. We'll send them directly through our servers. They'll be able to see what the radar looks like inside the eye and be able to get that eye diameter. Is it 4 miles wide? Is it a 25-mile wide eye? And that's all critical to the forecasters, right?
Yeah, that structural information is really important, and the combination of all the data that come off the aircraft here improve track and intensity forecast by 10 to 20% in the forecast models we use for guidance. You talked about using the radar data and tactically, so you can talk a little bit about how the flight crew stays safe during a mission. What is it like flying into the eye of a major hurricane? How bumpy does it get?
Yeah, I mean, that really touches on the last radar. So the last radar is our nose. We'll be right up there here in a second, but the nose radar is what we're using to tactfully maneuver through the hurricane. And so without the nose radar, we wouldn't be able to really see what's up ahead. So that's the radar we're really relying on to maneuver through the storm. And we get to see that on our station here. As you walk up, you're actually passing a lot of the stations where our scientists will sit and look through a lot of our data as well. And we'll eventually arrive up here in the flight director navigator section, where all those radars that we have talked about are really viewed. And so you can see there's a lot of real estate here, is what I like to say, right? A lot of screens for the meteorologist on board. And that's really important because this is the seat. The individual who's working here is making sure that all the data that's leaving the aircraft is ground truth to provide NHC with the best database quality possible. So you can see the nose radar would usually appear up here on this screen. The belly radar, the MMR I talked about, would appear here. And we can also pull up the tail Doppler radar on that main laptop there, as well as our flight level data. So this is where the meteorologist sits on board. Typically we have 1 to 2 meteorologists on board, and then the navigator sits here. And the navigator, very important role because it's essentially telling everybody where are we located, right? We work in some really remote areas. And so not only does this individual mark the center when we're out there hunting the center of the storm, but they keep those constant communications, not just with people on the ground, the FAA, but also the Air Force, who might be out there with us too.
Yeah, that's great. And as we step on up into the cockpit, you can see there's 3 seats here for pilots, co-pilots. There's a lot of technology, a lot of buttons, a lot of switches that require a lot of work to keep this plane in the air in such a harsh environment.
Yeah, you also see Kermit up there in the windshield. He likes to do a little bit of a dance when things get a tad bit turbulent. So that's a little fun thing about this aircraft. Miss Piggy is in the other one in the windshield. So in the flight deck here, you'll notice the 2 seats for the pilots, and the left seat and the right seat. The center seat here is for our flight engineer, another vital role. This individual is maintaining the storm speed, which people think, like, what do you have to do to get through a storm safely? Really, storm speed is a huge part of it, right? So for us here on the WP-3D, it's 210 knots. And the reason why that's important is because it's what keeps the aircraft safe, doesn't stall, doesn't overstress the aircraft when we're flying at that specific wind speed. And so I like to describe it as if you go over a speed bump in your car too fast, or if you go over too slow and you do that rock. This individual is literally working on the levers to make sure that we're doing our best to maintain that 210 knots while the pilots are keeping the actual aircraft straight and level. Yeah,
it's really amazing. And just a reminder of how much teamwork is involved to do this, and how many, lots of brave men and women who work at the Aircraft Operations Center, as well as at the Air Force, who knowingly and willingly fly right into hurricanes, something that most people would really prefer to avoid. But the data they collect is, again, some of the most valuable that we have. Real quick, we'll walk back towards the rear of the aircraft here, and I'll ask Nikki, so you might be on this plane for 12 or 13 hours. You're not in the going through eye wall penetrations the whole time. So what does the crew do if there is any sort of downtime, or if they need a break, or if they need to eat? How does that happen on board?
Yeah, absolutely. So we might be going through the eye of a hurricane 3 or 4 times, and so what that means is most of the time we're strapped in our seats. Seatbelt sign is on, seatbelt sign is fastened, as you would expect. But when we're going downwind in between those legs, we call them repositioning legs. We'll find a moat in the hurricane environment, and we'll fly downstream. In that 15 to 20 minute block of time, you have about 15 people that have to use the restroom, maybe heat up their lunch for the day, their breakfast, depending on what time we're flying. And so, yes, we do have some of those human factors on board that are vital. We have the bathroom, we have the coffee pot, we have the microwave, and the bunk beds, actually. So our flight engineers and our pilots, it's a very strenuous job flying this plane for all those hours. And so they will take rotations where they can take some time to relax. Strap themselves in. There's actually a seatbelt in the bunk bed, right? You've got to keep them in there safe. Good
idea, right.
Nice curtain to pull so they can take a break, get some shut-eye before going back in for the next pass.
Yeah, it's really important to remember that there are a lot of people on this plane. It's not just an instrument package flying in. There's people on board who are doing a really important job and collecting data so hopefully everybody has a lot of confidence in the data that comes off this aircraft that helps us have a lot of confidence in the forecast we make at the Hurricane Center. So thank you, Nikki. It's been a great quick tour of the P-3. Just a quick reminder, we got a couple more days of the Hurricane Awareness Tour coming up. We're going to be in Charleston, South Carolina on Thursday. We're going to be in Sanford, Florida on Friday. And in particular in Sanford, the tour is going to be open to the public Friday afternoon. So you can get more information at hurricanes.gov and click on the link up at the top there about more information on the hat. And so thanks again. Great to be with you today. I'm Mike Brennan from the Hurricane Center, signing off from Norfolk.